Hello everyone and welcome to Trace Your Packets. Bit of a new channel, something very different for me. I'm actually going to be going over a lot in this channel specifically about Cisco, CCNA related learning and education. Something I've focused on for quite a few years at this point. I think it's been a good, I'd say probably about 8 years that I've focused on it for. I've not completed my CCNA. I've done the studying though, probably about 5 times all the way through. Just never managed to get to the point of taking the test. It's not something I've ever really been interested in doing 100%, mainly because financial reasons. But it's something I know a fair bit about, and a friend of mine has asked me for help recently, so I thought while I'm kind of working through and trying to teach him in a very basic format, because I don't want to be someone who throws a load of complicated words at you and confuses the hell out of you. We're going to go through this step by step. I'm going to cover things, explain things a bit more rather than just the base documents that we typically receive, and I'm going to see how things go, have a bit of fun with it, and we'll work from there. So now that I've explained a bit about what I'm going to be doing on this channel, I suppose, we'll take things from here. We'll move through, and I'm going to start out with my local network and make a way through from there. We will be showing a bit about Packet Tracer, the use cases, things such as that in this first episode, and we'll basically just explain what certain components are, what the purposes are, what the full reasons behind it is. So, my local network. My first part that I really want everyone to think about, and I asked this question for quite a few people. What do you believe the internet is? Now, I'm going to give you a few seconds to sort of formulate an idea in your head of what the internet actually is. Because if you've got any interest in networks, it's a very good first question. Because a lot of people immediately just go, well, it's the thing you go on the browser for. No, that's the World Wide Web. That's websites. The internet is basically just an interconnection of a bunch of networks. Now, a network is literally just the capability of connecting two devices together. Now, we have since gone way past that, but that was the very bare bones basic version of a network. You can connect two devices together and you're able to network them. It's a bit like social networking. Meeting someone new, two people, you've socially networked. Imagine that with devices, basically. Now, there are many components to what a network can have. You've got your servers, which are basically just PCs on steroids. You've got basic laptops, PCs. You've got your routers, your firewalls or ASAs. You've got switches, KVMs. There's tons, honestly. There is so much, it's hard to go through just off the top of your head. And even now, we're now moving to the idea of going to cloud instead of just bare-bone devices. So, yes, the internet is basically just a bunch of networks interconnected. So, my home network connects to other people's networks, which connects to the broadband company's network, which then connects to another company's, and so on and so forth. And basically, it's just a massive web of interconnected devices. The World Wide Web, on the other hand, is basically just a bunch of websites hosted on servers that are accessible via the internet. That's basically the difference. And depending on which way you want to argue about Google and search engines and all that good fun. But we'll not get into that. So, to start with, to understand truly like networks and what you're wanting to learn from this, a CCNA qualification is really good. Even now, even when we're moving to cloud, it's a bit frightening for a lot of people in the field because moving to cloud is moving away from these hands-on devices. Now, I'm not looking at it that way yet, because I think we still have quite a few years of what's called a hybrid model, which is basically where you'll have part cloud, part on-site equipment. Now, the cloud system is very much similar principle, basically the same principles that you will learn through doing a CCNA or doing your Cisco qualifications and using packet trace, stuff like that. But you're just taking the equipment out of the equation. Personally, I prefer equipment. I think it's a lot more fun. I don't know about a lot of people, but I enjoy getting my hands on with things and solving problems. It's my big thing. So, the first thing I want you to think about, what are the things that make up your network? Now, for a lot of people, it's going to be mobile phones, probably a tablet, any smart home equipment like a Amazon. I can't say a name because I've got one next to me. Could even be PCs, consoles, Fire Sticks, anything. Those all will make up your network. Now, as this does as a sample, manufacturer, Apple, device, iPhone. For me, it'd be Samsung Galaxy smartphone. It's a mobile device, so it can be transferred anywhere. It runs on a wireless connection and a Wi-Fi and cell phone. So it can both use Wi-Fi and it can also use cellular data plus a bit more. Cisco, cable modem. A modem is basically just a hub. So yeah, modems are a little different actually. I find it a bit complicated to fully explain that, but we'll move on to it as and when. Home office, wired, cable TV, coaxial cable, and an Ethernet cable. I will be calling an Ethernet and not an Ethernet, because there are some people that I will argue with on that one, and my friend is one of them. As I said, I'm not doing this seriously. I will be learning bits myself as we go along, because it's been a while since I've last covered this, but I just want to go over the basics to start with and move from there. So, now that we've basically covered the basics of what's inside your network, the reason I wanted to cover that, to be honest with you, is so that you understand what devices classify and count. Because a lot of people will think of a network and go, well, it's whatever connects to the hub. You're correct in that regard. But then you've got to think about what goes further than that. Now, I'll probably put a couple of photos around, I'm not sure. Actually, you know what, we'll put it up on the interwebs. So, I actually have I have these at home, so I decided to buy some equipment for it. I have some what's called switches. These are 24 pin switches. I own 3 switches, 2 routers, and I've not got an ASA. I did attempt to get one, but they're a bit pricey. Getting equipment like this can be quite pricey, especially when all you're doing is practicing and learning. It's expensive. So I'm just going to quickly go over these, because these are things that most regular people will not come across in their day-to-day life. So this is what's known as a switch. Your switch is capable of doing many things. It has a lot more configuration than what a lot of people use it for. I don't mean that in corporate environments, I mean day-to-day people, because a lot of people will buy like a 4-pin one or an 8-pin, and basically they will use it in regards to adding more ports so that they can have more Ethernet cables going around. That's what it is for a lot of people. In actuality though, you can split IP addresses, subnet, and do many other things. Prime example actually of how much you can split these things up. Got an 8-pin there compared to the 24 pins, and they're absolutely amazing. I actually have a lot of fun configuring these because there's just so much you can do, and being able to split up a network in our environments now, for a corporate environment, it's phenomenal. In regards to personal use, there's very little reason you ever would. Don't get me wrong, some people have got reasons to, like splitting networks so that kids will be on one, parents will be on another, have certain parameters scaled down, and certain blocks put in place. All depends on what you plan to use it for, but in my use case, I've got no purpose for that. So, I'm going to show you now how to, basically, we're going to build this simple network. Now, yes, you can follow along as easy peasy, lemon squeezy. It's really not difficult to follow along with these, and it is showing you this bit. I've just realized it's not even showing you actually how to do this packet tracer, so I can go through now and show that. So what we're going to do, we're going to start off. We're not going to actually have anything more than just a switch and two PCs. So just to quickly go over how Packet Tracer works, you have network devices, which is your routers, switches, hubs, wireless devices, security, and WAN emulator. A WAN is just your wide area network, LAN is local area network. Two keywords you will definitely want to remember. Then you get your end devices, which are usually your PCs, servers, phones, voice over internet protocol, that sort of stuff. You've got your home devices, because you can actually like fully set up as though you've got houses and then corporate environments, and you can basically build an entire network infrastructure in this system. And it's really cool. It's really impressive to do. You've got different components, actuators. You're never really going to mess with the component side. The connections we care about, because these are your cabling. Then you've got structured cabling as well, which you can play around with. Miscellaneous bits, these are just some like older components at this point. I actually still use a couple of these. And multi-use connection. So, for example, you want more than one device, one user to be able to log into a single machine, you can set that up, or show at least the use case for it. So, as I said, I'm going to set up two PCs connecting straight to this switch. So we got PC 0 and PC 1, because computers will always connect starting counting at 0 and then go up to 1. 0 is 1 to a computer. That's what I'm trying to say. So, right here, we've got two PCs. And you will notice I used the automatically choose connection type. It's best to know what you're choosing, because sometimes you will not choose the correct one, even though you want to. But basically all I chose was a copper straight through cable. It's basically just a very basic Ethernet cable. You got your fiber, your coaxial, serial DCE, serial DTE, octal, IoT custom cable, and a USB. You won't need all of it. Oh, and a console cable. I always forget about that one. You won't need all of it, but it's worth knowing what you've got. So, these two PCs. We have an easy way to do it, which a lot of people will take the easy way. I personally prefer to go through and we'll set these things manually. So, I always have a bit of fun rather than going into this config interface. Go into your desktop, ipconfig, and it's basically as though this is an actual computer. So we're going through it for this. So we're going to set up a basic IP address for this. So we're going to start out by using a private class IP address. We're going to use 192.168.1.10. That's going to be the IP address. Subnet mask is going to be 255.255.255.0. That's going to be the default. Now, I'm not going to need a default gateway yet, because we don't have anywhere for the traffic to go to as default. Basically, all default gateway is if you've got a router, that would be these devices' default gateway, because all traffic would need to go through that device to reach this device. So if something was coming from the internet, it would go through the router into that device. It would be directed via the IP address, and then the default gateway is when this device needs to reply to whatever's been sent by the internet to say, yep, I've received that. It goes back, knows to go straight to the router, because that's where the default gateway is set, and then the router will send it out from there. So because there's no router, no need for that as of yet. Next, we'll go in here. Now, as I said, I set the first one as 192.168.1.10, so this one's going to be 1.11. Now, to make sure that we are 100% correct here, I can set both of these up quickly. I do apologize. I can open the terminal. Okay, here we go. We can ping 192.168.1.11. as long as my terminal's working, which it doesn't. Oh, command prompt, my apologies. Ping 192.168.1.11. As you can see, I'm getting an immediate reply from this device. Now, if you want to see this a little better, which I'll be honest, sometimes it is pretty cool, you can go to simulation over here. And what simulation does, it allows you to actually check packets from one device to another. So I'm going to add now a piece of mail to go there. We're going to play that. You can see it goes straight across. It's received by the switch. Then the switch is going to proceed to send that device straight on to PC1. Now, that's just for it to reach that device. Now, it's got to feed back so that this knows that the ping was received. So when you actually use the ping command, what it's doing is it's sending out a signal to reach this device, and then it is trying to receive that response back just as quick. As you can see here on this side, you can see exactly what happened. You can see this one actually failed the ping. So it reached, but then it didn't go anywhere else. And these happen. I think this has actually just been a bit funky. Oh right, it's just checking from the switch. It's just checking that both of these devices are set up. They're not properly set up by me. But that's its own thing. You can see actually how long it takes as well. It took 0.004 seconds to ping from this PC to that PC. And that's genuinely how long they take. This, I believe, is actually just checking for, it's checking for spanning tree, which is fine. Well, that's TP protocol, which we're not really that bothered about. So we're going to go back to real time. As I said, this is just a very basic setup. This is the sort of thing we have here. So we actually have this set up, if I am correct here. Yeah, this is showing you how to do it on a computer, which is fine. Command prompt. You can check the IP address, which, I mean, we can do here. If I just pull this up, ipconfig. You can see right there what the device is on PC1. That's not a problem. And then if I pull up PC2, ipconfig, you can see that's the exact same there. Well, the correct one. So that's completely fine. No problem at all there. So what I'm going to do from here is, considering we've done the first part, I think it's going to be interesting to actually set up the router a little. So what I'm going to do is I'm going to pick out a router, which will go with this one here. The routers are a little more difficult to configure because I am not going to recommend to anyone to just configure it via this. I personally think you get a lot more experience, a lot more understanding via configuring via the CLI, or command line interface, rather than using a GUI for everything. Now, I'm going to be pretty straight up with everyone, straight off the bat, as I have been pretty much from the beginning here. I'm not the best with these things, so completely understand if I'm going to take my time. And you are not going to remember every command. I can assure you, you're not. I have 2 books that I basically classify as my networking Bibles for anything to do with Cisco. And even to this day, I still use them often when I'm messing around with Cisco related things. I personally like to use a different application to this, called GNS3, because that does what's called, my apologies, my memory is just fried on me. That actually basically runs it in a it virtualizes it. That's the word I'm looking for. It virtualizes the entire network, which is really impressive. Packet Tracer, on the other hand, does not. It basically just runs set as what it's expected to do. So it's not as advanced as GNS3 is, for example, where you can set up a full network digitally, including virtual machines running as PCs instead of the standard stuff that this has got. So it's very impressive. I really like it, and you can connect the virtual machines straight to the internet through GNS3 and the network that's running there. So really impressive bit kit. I might show you that one day, but for now, this is what we're focusing on. So, would you like to enter the system initial configuration dialog? Always just press Ctrl+C, that'll get rid of that straight away, and then press enter. Now, whenever you first connect to a device, Oh, I did forget one thing. You gotta actually connect this thing up. Make sure that it's connected straight to the switch. So whenever you connect up to a device for the first time, you want to do a bit of housekeeping. Is my usual thing. So to get into a place, I do apologize. I forgot. If I'm teaching this fresh, I should do this correctly. So there is no real help command. As you can see, it doesn't like it. It tries to translate it. Moving straight back on. Go back to the CLI, and what we're going to want to do is a bit of what's called, or what I like to call, housekeeping. And that's basically just making sure that if, let's say, the device, Control-C, get rid of that. If the device is going to be, let's say you've got multiple routers, which eventually you are going to have to simulate multiple networks connected simultaneously, you are going to end up in a place where you forget what the router is, forget what it is, what it's supposed to do, what it's for, so on and so forth. So straight off the bat, what I'm going to show you first and foremost is if you get stuck at any point, you can't use the help command, but what you can do is you can use question mark. Now, the question mark will always give you an option when you're either typing a command or if you are stuck on what possible command it is. Now, you'll notice in here we have the enable command, which turn on privileged commands. Privileged is a mode that usually we lock down quite heavily because basically that's how you can make all the edits in the world to this system. So I'm just going to put it as ENA because you can shorten a lot of these commands. If you want to quick complete, press tab and that'll finish the command immediately. You can then put a question mark if you want, and this basically is how you can see at the end of a command what possible things you could end it with. I will show you a better example of that in a second. So if I put hostname, doesn't seem to be picking that up, which is fine. I'm just going to then put, let's just go R1. Oh, wait. Oh, I see. So I've messed up there. Memory is, as I said before, not 100%, but we'll go through. So these, as you can see, there are much more commands to this. To go down, by the way, if you want to go a single line, press enter. If you want to go multiple, just space, and that'll finish the load off. So you can see here there are a lot more commands to choose from. Because we're wanting to do what I call housekeeping, we're going to go into config. So there we are. Oh, I remember now. It's supposed to be conft. So yeah, your conft, that's basically configure terminal. That's what that's supposed to be. So I always write it as conft, but if you do that, that's how you're supposed to get into it. And basically you're just saying, I want to configure the terminal. Now in here, as I said before, I'm going to do hostname. If I then put a question mark after that, it's going to say this system's network name. So I want to call this system R1 for router 1. You'll see right at the beginning here, it's no longer called router, it's called R1. From here, what I would like to do, I'll actually just show you. This is how much more there is in configure. In comparison, there is a lot that you are basically able to do. To a lot of people, this is going to be very frightening early on. What I'm going to say to you straight up off the bat is you are not going to remember all this. You will remember bits and bats. My apologies. You'll remember bits and bats as you go. It's frightening when you first see it. The more of these that you do, especially considering these will literally hold your hand through the entire thing, tell you how to do it, you're just remembering the process at that point. How do I get here? What do I need to configure? What is it that I've configured? If you remember those things, you will be just fine. So, next, we need to configure this Ethernet port. The reason for that is, as you can see, these red triangles. Green triangles means it's working, the network is up. Orange circles means that it's up, but it doesn't seem, it's still trying to connect. And red just means straight up it cannot connect. So I'm going to quickly just go to preferences here because I like to have a certain option on that I've noticed is not on, which is annoying to me. There it is, always show cable ports. And you know what, because I think a lot of people agree, that's fine. I'm going to turn that off for now. So basically the reason I turn this on just tells me what the port labels are. So fast Ethernet 0, fast Ethernet 2, fast Ethernet 0, fast Ethernet 1, fast Ethernet 3, and Gigabit Ethernet 000. That telling me what the port is just allows me to figure out from there where I need to go. So if you were reading it from the router, it would just tell you on the router. That's kind of how they're labeled. So what I need to do, I know I need to go into an interface because that's what the Ethernets are. From there, we know it's a gigabit Ethernet. So we know we need gig Ethernet. So just type in gig, press tab, and then you can do a question mark. So we know we've got to do 0 to 9. We know the first one's 0, then it wants a slash. So basically, we just set this up as we go. Put space after, and you'll get CR. CR just means press enter. Right, now we're in what's called configure interface, or conf-if. Now, this is basically just saying, what do you want to configure here? So there are already some commands on here, which I will show you in a moment. Actually, you know what, I'll show you that now, while we're here. So if you are just in enable mode rather than configure T, you can run just the run command. Oh, it's not run. Just cut this entire segment, Rory. Ah, there we go. So we can do what is called, I think it is actually just show run. Yeah, it is. So show run is show running config. And we're going to run this, and this will show the running configuration of the entire router. Now, any Cisco piece of equipment you can run this on, and it will show you basically all the configuration. Now, the configuration, thankfully, is not too complex to understand. And basically, we can see, so straight here, I'm actually going to, we don't really need that bit, so we'll just do this here. So, from here onwards is the configuration. Current configuration is 642 bytes. What version it is? There is no timestamp log data. There is no timestamps debug. There is no service password encryption. The host name is R1, which we already set. IPsec, but no IPv6 Ceph. Spanning tree mode is already set up by default. And then if we look at all the ports here, so the 3 gigabit Ethernet ports, they have no IP address. They're all 3 shut down. Their speed is set to automatic as well. Interface VLAN 1, no IP address, shut down. IP classless, IP export version 9, what is that? Line config 0, line aux 0, and line VTY04 login. That's all that's set up on a router by default. Even realistically, there's no host name set up by default either. So, as I said before, we're going to go back to conf-t. These are commands that will basically just become part of your day-to-day. You'll remember them off the top of your head. ENA, enable, conf-t, configure terminal. It's something that just happens. So, interface, gigabit Ethernet, 000, enter, Fantastic. So from here, we're going to set up an IP address. Now remember I said earlier that these needed a default gateway to be able to talk to this. So I'm going to set the default gateway. It has to be part of the same IP address range. I recommend, especially as a Class C IP address, you set it as 1.1 or always either like the first or the last IP address, one of those. You'll get into IP addresses a lot later. It's something that's a bit more complex to understand rather than the basics of getting to the grips with things. And especially when you get into grips with packet tracer as an application. It can be a bit confusing, so I prefer to let people have a bit of a play and build a network. So we're going to set up the IP address, but we can't just put the IP address. We also need the subnet mask. For now, all you need to know is it's definitely going to be most times 255.255.255.0. Once that is done, you can press enter. Now, as I said, if this was going to, there is more config on this IP address, which is that it's shut down on this interface, which isn't good because it won't allow us to connect to the router, the switch otherwise. So what we have to now type is no shutdown. All no means is basically remove the command or delete that action. So no shutdown, and you'll see immediately once that was done, that interface is now up. Line protocol on interface gigabit 000 change state to up. You'll see it's green and it's orange. Now, these will be able to connect very basically. Or at least it might work one way but not the other. We'll see here. Request timed out. Ah, there it is. They've made it through just fine. Now, the only reason, as I said before, for these to basically go further is if you were to add more parts to the network. Now, as of the moment, I don't have a reason to do that. I'm just showing you how to basically set up a very basic network as things go. There is no way for, as of the moment, for the network to pass to anything else. So there's no need for me to go any further with that yet. With that, though, that is the first episode I'm going to show you. Bits and bats of. Trust me, there is much more to Cisco, and I will become much more confident at explaining and detailing things as I go. I do apologise if it was a bit bumpy for the first time, and if I missed bits or simplified things that I really shouldn't have. I'm sure there are much better people out there than I am at this, but what I will say is I'm trying to explain it in the simplistic terms possible so that it's not overly complicated and just have a bit of fun with it. That's all learning networks is for me. It was something fun, something enjoyable to do, and I learned so much from it, and I enjoyed myself thoroughly through the entire times I've done it. And I work in the IT field professionally. I am just an IT technician at the moment, but I do have a fair amount of knowledge on this. I completed my university degree based around networks and security, so I've got a fair bit of knowledge, not compared to some people, trust me, they're much better, but I hope at least it helps with something. So with that all said, thank you for watching, and if you think if you enjoyed and learned something from this, please leave a like, leave a comment, explain a bit if you want me to focus on something. More than happy to do so, but just let me know. Anyways, thank you all for watching, and I'll see you in the next episode. Bye.